Last day we talked about charging by friction, which is what happens when you rub two different types of materials together. One of them has a greater love for electrons and it steals them from the other, meaning that the one that loves electrons more, the one that has a higher electronegativity, becomes negatively charged, and the other object becomes positively charged. In this particular lesson, we're going to talk about charging by contact and charging by induction. Obviously, contact means that you've already got something that is charged. So you're going to have a negatively charged, let's say in this case, object. And when you touch a neutral object, those electrons are going to jump and escape or discharge from the negative object, and they are going to jump to the neutral object. That means that the original negative object now becomes neutral, and the neutral object becomes negatively charged. It just gives its charge by contact. I could also have it go the other way around. I could have a neutral object coming very close to a positively charged object so that the negative charges jump from the neutral object onto the positive charge. This guy now becomes neutralized and this one becomes positively charged. Now here's an example of a diagram for an electroscope. What's an electroscope? Well, you're going to be building one of these in your next lab, but here's what one of the ones would look like if we were back in the lab at school. You would just get yourself a glass container. You'd have a piece of metal that runs all the way up through with a little metal head on it. Two little pieces of very thin metal. You're going to make yours out of aluminum foil. And some kind of rubber insulator to stop the actual metal rod here from touching the sides of the glass. In your case, you're going to use a little piece of electrical tape to separate the paper clip from the actual lid of the jar that you're going to be using. You'll see that in the lab that's been posted. So there's a real electroscope, but we don't have time to draw such a fancy drawing, so instead we're going to just draw a sketch, which you'll see here. So there's the head, there's the metal rod, and there's the metal leaves, the pieces of metal that are dangling down. Now when we have equal positive and negative charges, we can say that the head is neutral, and then equal positive and negative charges on the leaves as well, so we can say that the leaves are also neutrally charged. So overall, this entire electroscope is neutrally charged. Now when we come near it with a negatively charged rod, so we've got extra negatives sitting on the end of this particular piece of material, when we just come near, but we don't make a lot of contact, what we'll start to do is have these negatives in the head will begin to move down into the leaves. Now, if I'm quite far away still, they're not going to move very far. But what's going to happen is they will start to shift down, which will then start to make the leaves a little bit negative. And you can see that I've moved them down right here. Now, I still haven't made contact in this picture, but the negatives have been repelled from the metal head and they've moved down to the rest of the metal area. Remember that metals are very good at sharing their electrons, so it's easy, and they're very conductive, so it's easy for those negatives to escape farther away from the metal rod. Because both leaves end up being negatively charged, like repels like, so they are going to move away from each other, and you will literally see the little pieces of metal will move away from one another as they repel. You're going to see that in your lab when you create your electroscope next day. Now, if I actually make contact so that this negative rod actually touches it, because the head of it is now positively charged, those electrons are going to jump to the positively charged head. And when I remove that rod, because I've got extra charges now here, overall, even though it was a neutral electroscope before, it's going to now be a negatively charged electroscope because I've given away for an extra electrons, I've given a pathway for them to be added to the electroscope. So if you touch something with a negatively charged object, the new object becomes negatively charged as well. So negative by contact creates another negative. So when that rod is removed after contact, it is neutral because it is discharged. So the rod gives up its electrons, it goes away happy and neutral, and now this guy is negatively charged. When we charge by induction, we're going to force or induce, that's what the word induce means, it means to force. We're going to force a charge on the neutral object without ever actually touching it with the charged rod. So we start off again with the neutral head of the electroscope and some neutral leaves, but this time we're going to attach a wire that's going to go off and be attached to ground. Now ground could be, in your case for your lab, you're going to be maybe attaching that piece of wire to a metal tap in your house, a water tap in your house, and that's going to connect it to the earth so that we have an infinite number of electrons available and an infinite number of places to put electrons should we have extra electrons. This time, when I come near it with a negative rod, the electrons, instead of moving down into the leaves, because the wire is attached first, they actually move into the wire. This is called taking the path of least resistance. The electrons will move wherever it's easiest to go. And because this wire is attached above the leaves, they're going to move into the leaves. Okay? So notice we haven't touched the electroscope head. We've just come near and we've forced those electrons to begin to move. Okay? Now we're going to leave the rod nearby and then remove the wire. So in second case, the rod is near, but the wire has been removed. We're still pushing whatever those extra electrons are, we're still pushing them down into the leaves. And because we've got an overall equal number of negatives and positives, the leaves remain neutral and they stay flat and down, just like they did here. They were still neutral, so they didn't fly up, they didn't repel. But as soon as the rod leaves, these little electrons that have been squished down and have been pushed away and repelled by the rod no longer have anything repelling them, and they will spread out over the entire electroscope. But because I now have less negative charges, the charges that got lost to the wire, because I now have less negative than positive charges, overall I now have a positively charged electroscope. So I came in with a negative rod, but I ended up with a positively charged electroscope. So when you charge by contact with a negatively charged object, the electrons jump to the new object and also become negative. So the negative object creates another negative object. But when you charge by induction with a negatively charged object, that neutral object actually becomes positively charged because you forced it to lose electrons. So a negatively charged object that comes near without touching can create a positively charged object. Here's the opposite condition. What happens if we come near with a positive rod? Well, the positive rod in this case, rather than pulling positives, because remember the positives are not going to move. They're in the nucleus of these atoms. We're not suddenly pulling all the metal atoms up. The positives stay put. Instead, the electrons, which are allowed to move, get drawn up towards this rod right here. But because we have a wire attached, they're going to come from the wire rather than being stolen from the leaves. Okay? So as it comes near, I'm going to actually be adding more electrons and drawing them in than I had when I first started. Well, the rod is still near. I'm going to remove the wire, and I'm still drawing those electric charges, but now they have no way to escape. They can't leave back out the wire, so that when I remove the rod away and those extra electrons are now free to move across the entire electroscope, they make the leaves negatively charged, which means that they are going to repel each other. So when you are charging by contact with a positively charged object, the electrons would have jumped from the rod in this case to the new object, and they would have become positively charged. So contact, you're going to get the same. The rod becomes neutral, and the new object, they jump to the rod. But when you're charging by induction with a positively charged object like we just saw above, the neutral object becomes negatively charged because it got new electrons from the ground that weren't there before. So if we were to sum it up, we would say that when you're charging by friction, an object with a stronger hold on electrons will steal them from another object, and you're going to get opposite charges. So one thing becomes negatively charged, one thing becomes positively charged, and you can use the electrostatic series to figure out which one will become negative and which one will become positive. When you're charging by contact, something that is negative, when it touches something else, makes that thing negative too. Something that is positive will steal electrons, and it will make the other object by contact positive as well. So you get the same charge. But when you are charging by induction, a negative rod will create a positive other object, and a positive rod makes a negative object. So that's an opposite charge again. Please memorize this box. This is a very important bit of information. And if you have any questions, please let me know. This is the end of this lesson.